This video is about direct variation. A direct variation is a special type of linear relationship, so it's a line that can be written in the form y equals kx. So k is much like the slope. It is the slope, where k is a non-zero constant. So it's a number that's anything but 0. Okay, and if we think about that, if k was 0, would the x exist? No, so it can't be 0. And that k is called the constant of variation. So this equation, y equals kx, is linear. It's a lot like mx plus b. Okay, so if we have y equals mx plus b, and we have y equals kx, the m and the k really stand for the same thing. The only difference is that the y-intercept must be 0. So we don't necessarily want a b. If there's a b back there, that means it's not a direct variation. So it still needs to be linear, but the b has to be 0. And what this means is it has to run through the origin. If the y-intercept is 0, it must run through the point 0, 0 on the graph. So here's a few examples. If we have y equals kx, it says what is the constant of variation? The k. So these are all set up nice for us. So if we have y equals kx, k here is going to be 4. The second one, it's y equals kx. So k is going to be -6. And on the third, this one's set up so that k equals 1/2. On the next problem, it says, is this a direct variation? If so, what is k? Well, if my direct variation equation is y equals k times x, I have to first solve my equation for y, because this says y equals. So to solve for y, I'm going to leave this y term for last, so this x has to go first. So to make a 0 pair, I'm going to add 3x to both sides, so that I have 5y equals 3x. And then to solve for y, I need to divide by 5. So now I have y equals 3x over 5, or I can rewrite this as 3 over 5x. So is this a direct variation? Yes, it is, because I don't have plus anything back here or minus anything. So my y-intercept is 0. So that means my k value is 3/5. So yes, this is direct variation, and my k is 3/5. The next one, again, I have y equals k times x, so I need to solve for y. So I'm going to subtract 2x from both sides. I cannot combine my -2x and my 10 together because my 10 does not have an x. They are not common terms. So I have y equals, and I'm going to put the x first, so -2x plus 10. Is this a direct variation? No, it's not, because I have plus 10 back here. My y-intercept would be at 10, not 0. In a table form, if I have y equals k times x, if I was going to solve for k in an equation, so this is just kind of off topic real quick. If I wanted to know what my k was, to solve for k, I could divide by x. So I know, these will cancel, that k is the same thing as y divided by x. So over here, to see if it's a direct variation, all I have to do is do y divided by x. If they come out to the same number, it's a direct variation. So my y divided by x here would be 6 divided by 1 which is 6. 18 divided by 3, which is 6. 30 divided by 5, which is 6. They're all the same number, so is this a direct variation? Yes. So I know my k equals 6. So now I could actually write an equation really quick. Y equals k times x. So y equals 6 times x. And if I fill that in here, y equals 6 times x. If I do 1 times 6, that's going to give me 6. 3 times 6, that's going to give me 18. 5 times 6 is going to give me 30. So that's what's useful about a direct variation. When we're looking at it graphically, if we know that the y-intercept has to be 0 back here, it has to run through the origin. Does this graph run through the origin? Does it have a y-intercept of 0? No. So this is not a direct variation. Let's look at the next one. Is this a direct variation? Yes. It runs through the origin. So yes, it is going to be a direct variation. How about this one? No, because it does not run through the origin. It is not a direct variation. In number 10, the slide 10 says the value of y varies directly with x. All this is saying that y varies directly with x is that it is a direct variation. So if it says that, then it does mean that it's a direct variation. It says y is 6, x is 12. So if I had a table here, I have y is 6, x is 12. Oops, wrong number. Find y when x is 16. So there's lots of ways to do this. One way is to do the y divided by x like we did before. So I have 6 over 12, which reduces to 1/2. Okay, so if I had an equation, y equals 1/2 x. So if I do x times 1/2, that's going to give me that y is 8. So I should have 16, y value 8. So there's my y value. Another way to do this problem, if I have y equals k times x, use the first ordered pair. Okay, fill that in. So if y is 6, that's going to give me k times x, which is 12. If I solve for k, I could divide by 12. That's going to give me 1/2 equals k. Same number over here. So then to fill it in, y equals k times 16, the x, I would have y equals 1/2 times 16. So y equals 8. So really, these are two different methods. This is one way you could do it. This is the second way you could do it. Whichever way works best for you, then do it that way. If you see it best on a table, do it as a table. If you see it best as an equation, do it as an equation.